Hello, and welcome to the very first Actual Tech Media Expert Series webcast. Our event today is Understanding SQL Server on VMware Storage Options. Today's webinar is sponsored by Pure Storage and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this event and to get this great series kicked off. So we want to thank our sponsor today, Pure Storage, for making this special educational event possible. Pure Storage can help you accelerate your data for SQL Server and VMware. Scan that QR code to find out how Pure Storage can help you eliminate underperforming workloads, costly downtime, slow response times, and complexity. I'll be moving on from this slide, but if you didn't get your phone out in time to grab the code, you can find a Pure Storage PDF in the handout section of your console that has the same scannable code on it. These Expert Series webcasts are designed to be highly informative, technically valuable events, but we want you to get the maximum out of it, so be sure to put your questions in the questions box, and we'll get to as many as we can at the end of the event. Also, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky attendee on the live event. Of course, you must be in attendance during the event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And with that, let's get to our fantastic content today. It's my pleasure to introduce you to our presenter today, David Klee. David is a Microsoft MVP, a VMware vExpert, a SQL Server performance enthusiast, and a virtualization architect. He spends most of his professional life taking mission-critical SQL servers and virtualizing them or migrating them to the cloud as the founder of Sequilibrium and founder and chief architect of Heraflux Technologies. You couldn't be in better hands when it comes to expertise on tuning SQL Server on VMware for performance. So I'm going to turn things over to David.
Welcome everybody to a highly technical deep dive on understanding SQL Server on VMware storage options. My name is David Klee. I am the founder of Heraflux Technologies and Sequilibrium Education. I have an absolute blast spending just about every waking moment playing with some pretty big toys out there. We do a tremendous amount of work around SQL Server virtualization and cloud enablement, performance tuning, and availability and business continuity architectures. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware vExpert. Here, unfortunately, is a really common scenario. You're the DBA, you wake up in the middle of the night because you're getting texted and paged and all kinds of crazy stuff around ridiculously high storage read stall. This is SQL Server's perspective on latency. You look at the operating system, you see not as bad a numbers, but still really bad. You call the storage admin, you wake them out of a deep sleep after a night of partying, and guess what? They look at the storage and they say, oh, 0.8 millisecond, everything's perfectly fine, go back to bed, your telemetry is lying to you. Nothing could be further from the truth. The problem is, in this kind of scenario, you usually end up with a I'm right, you're wrong sort of situation. It's not the right case. That's not accurate. Both layers are actually perfectly valid from its perspective. And that's because in between these layers, there's a ton of individual storage queues. So what we have to do, we have to figure out how to tune this stuff appropriately. So if we look at our infrastructure stack, this is a normal environment. You've got enterprise storage, a lot of cache memory, highly redundant controllers, hopefully all SSDs, but realistically, probably a mix. Well, you can have bottlenecks at the storage media itself. Then you have bottlenecks on the controller. And then there's the interconnects and networking switches between them. And then interconnects and uplinks from the individual physical machines. And then inside the hypervisor, there could be the hypervisor, it could be CPU, could be memory, could be backplane speed, it could be all kinds of stuff. And then move north to your database engine. Well, there's interconnects and storage controllers inside the operating system, be it Linux or Windows, and at the virtual disk layer. And then at the SQL Server instance layer, it's got its own storage engine. All of these things add up. You go further, you can end up with contention at the individual database layer and at the individual data or log file layer. There's a lot of components in here. And what we have to do is make sure that everything is rock solid end to end. Now zoom out and do this for all of your databases. It's not like it's a one-time fix as well. You got to make sure that any changes you make or anything that's new that's added, clean those up as well. So there are some really common challenges of performance, the stuff that I see all over the place. Two big ones: storage latency. And this is latency end to end, all the way from the underlying storage itself, all the way into that database file. And then there's database level file access, with a lot of that telemetry that is really going to start to stack up. So first, we're going to address operating system latency so we can set the proper foundation for these databases to scale and grow. So what we have to do, we have to kind of zoom out a little bit. We need to identify each component of the infrastructure stack, and this is on-prem, in the cloud, VMware, Hyper-V, physical, whatever. Bottlenecks in here will make everything above it worse. So what I generally tend to do for storage tuning, start at the bottom of the stack and work your way up. Because if you don't, it's kind of like you bought this absolutely amazing Italian supercar and it came with square tires. I custom designed those wheels myself. What we have to do, we just have to make sure that this layer is not the biggest bottleneck to performance. So start at the storage layer itself. Now, what really matters from a database engine perspective? The storage vendors will tell you IOPS, IOPS, IOPS. No, I need more IOPS than my demand. But what really matters to me is latency. This is the round trip time to actually do something on disk. Once we understand the storage speed to that underlying disk pool end to end, we can then start to tune. Now, latency, normal arrays you measure in milliseconds. The good arrays you're measuring in microseconds. Next, IOPS, I/O operations per second. It's a measurement of demand. Higher is sometimes better, but realistically, it's simply demand. If you got that Italian supercar and you want to go to get groceries, you're not pushing 200 miles an hour. You may have to hit an interstate where you're capped at 60 or 65, but that 0 to 60 time is what truly matters. So IOPS, I need them, but I'm not dependent on them unless, your storage just simply can't keep up. Then there's throughput. All throughput is IOPS times block size. That's it. So just simply monitor for throughput rates, make sure you're not slamming an interconnect, and you're good to go there. But again, latency, that round trip to commit that transaction to disk, that is what really matters the most. Now, a lot of this really depends on what kind of storage you actually have. So if you kind of fast forward through time, it started with the spindle. Think of it like an antique record player for storage. It's slow. It's high capacity. It's inexpensive. But you have extremely high latency. You have low throughput. And honestly, it's a moving part. So your reliability isn't generally as good as you can get with something that doesn't physically move. Now, move forward in time a little bit. We've got solid state drives. Now, they started with a SATA interface, which is essentially the same interface that these spindles had. And then they moved to a SAS interface for the enterprise, which is essentially the same thing, but with a slightly higher queue depth on it. And then a while back, they decided to reinvent the storage architecture completely and create a non-volatile memory express, or NVMe. These are extremely fast. These are extremely low latency. They don't draw a lot of power. They're very reliable, but they have the lowest possible latency out of everything in there. Now, these are brand new in the market, so to speak, in the enterprise. So if you haven't upgraded your storage within the last couple of years, you may not have these. Now, there's one here you may not have heard of. This is called persistent memory. Essentially, we now have DRAM that is persistent. So we can now treat memory, when we're talking nanosecond access time, like regular storage. It's expensive. It's a new format. There are a lot of operational changes that you have to make with your applications in order to really be able to take advantage of this. Chances are you may be running Linux at this point. Doesn't really work for a lot of folks. It's pretty new, but keep your eye on this. Now, when we talk about the cloud, same kind of thing. Standard hard drive, it's a spindle. Standard SSD, it's probably a SATA or SAS-based SSD, just based on the performance characteristics. Their premium SSD, it's generally NVMe. Archival tier, who knows? It's generally not directly shared storage. It's usually locally attached. So the challenge here, we have to buy what speed our application workload demands. We don't get a lot of visibility into it, and we usually don't have a lot of bells and whistles and knobs to go tune. I would argue it might not be a bad thing. Now, when you're on-prem, the SAN, the storage area network, this is the big enterprise shared storage device that most of us are going to be running. They're resilient, they're fault tolerant, these things are tough. They're built for reliability. And in the last 10 years, they started to be built for speed, which is really, really good. And by speed, I mean high IOPS, low latency. Now, you can connect them with fiber optics, fiber channel connectivity, or you can use regular networking, be it 10, 25, 100 gig networking if you need. But there's more to it than just a disk. Every one of these components has to be managed because it's all queues. Inside that SAN, you have storage controllers. This is essentially what handles the metadata management. It handles things like compression and deduplication and replication, and even multiple active controllers and load balancing in there. There's some read and write cache sometimes if you need it, but they're built there to basically fail over if you have a problem. There's the storage media itself. We talked about that. There's backplane interconnects. Then there's interconnects to connect this unit to whatever server you're trying to use it with. The things we really have to watch out for here: disk, pool, latency. I want to see what the storage itself is actually seeing. So if you have telemetry in your environment on this storage, go look at the disk pool itself. What's the read and write latency characteristics on there? You might find that you may be overloading this thing. Check the LUN level latency as well, because sometimes the disk pool may be idle, but the CPUs are saturated. And as a result, for any other reason, compression, deduplication, all kinds of stuff, you may see higher latency at the LUN than you do at the disk pool because the bottleneck is on top of that. And then the controller CPU utilization. We really have to watch out for this. Now, some arrays just simply don't present that information, which is kind of unfortunate, but some of them do. If the ones that you have don't, talk to your storage vendor. They may have some additional tooling or something you could acquire and actually go see that. Because in a lot of cases, the CPUs on these things are maxed out and the underlying storage is functionally idle. Now, these devices have to connect to your servers somehow. So we've got networking, we've got some interconnects if you're running fiber. If you're running regular networking, then these are just regular network switches. We have to go handle this stuff. Just please tell me that your server room doesn't look like this. It was an absolute nightmare. We had to go track a bunch of stuff down in there, and I wanted to just walk in here with a pair of hedge clippers and start over. Not really a good option, though. So every single thing in here has to communicate. And again, it can be a bottleneck. It usually isn't, but it's got to be validated and verified because occasionally we catch some pretty interesting stuff in there. If you're running fiber, then you're using host bus adapters or HBAs, and this is the storage fabric interconnect. If you're running regular networking, then you're running just network interface cards or NICs. So it could be RJ45, it could be SFP+, it could be QSFP+. It all depends, but essentially it's just fancy regular networking, a little bit more shielded cables. When we talk about speed of regular Ethernet, we got to be careful with this. On a 1 gig link, your theoretical speed is 128 megabytes per second, but the actual exhibited throughput is about 115-ish megabytes a second. And that's because there's overhead with the TCP standards. Go to 10 gig. We're at 1.25 gigs a second calculated, but realistically 940 megs a second. You go to 40 gig, same kind of impact. And the bigger it gets, the more this gap is there. Now note, that's with jumbo frames enabled. If you don't enable jumbo frames, you may end up with a performance penalty, and here's why. When the TCP standard was getting ratified by the powers that be, they realized that the equipment itself couldn't handle a very fast switching rate or a lot of payload in there. So they figured, we're going to send 1,500 bytes and then ask for an acknowledgement at the other end. Here's 1500. Did you get it? Here's another 1500. Did you get it? Not a big deal. It's called the maximum transmission unit size, or MTU. 1500 bytes is all the equipment can handle, but that was a long time ago. Well, you start looking at 10 gig, 25, 40, 100 gig throughput. That back and forth of such a tiny payload is slowing everything down. Go figure. So there are new standards out there where if you opt into it, you can assign a 9000 MTU. They call it jumbo frames. On 1 gig networking, don't worry about it. It's just not going to buy anything. But on 10 gig, 2500, you really need to enable this because you can see anywhere from a 20 to a 40% performance gain. The challenge with this, and this is something that your network team may push back on, it must be configured at all hops in the network end to end. So the switching, it's got to be enabled inside VMware or Hyper-V or any other hypervisor that you on. You just need to watch out for this because if they mess any of this stuff up after you deployment, you're trying to send too big of a payload, one piece in there can't handle it, and it goes, and then it has to send it backwards, it's got to fragment it, it's got to send it back out, and the whole thing slows way down. Now, this is really useful for things like network-based storage or backups, large file transfers, big ETL processes, things like that. It really does matter. Now, on the network switches, there's not so obvious bottlenecks with these things. We've been monitoring port uplinks and individual port maximums for a long, long time. If you have the telemetry in your switches, look for the peak data switching rates inside the network switch itself. Sometimes the actual throughput inside the switch can't keep up. Other times, there's controllers or CPUs managing individual groups of ports on there. So you need to actually go look for those as well. And sometimes you'll find that a lesser switch just simply can't handle the demand, even if you're not maxing out all of those ports. Let's go to the next layer in the stack. This is your physical server in your storage. So 2 types of main servers. There's rack mount and blades. I don't really have a preference between them. Usually rack mount have the ability to throw more hardware in it, but blade servers give you a more dense compute environment so you can pack more in with less. I'm pretty neutral on either one. Now, your interconnects, the HBAs on here, if you're still running Fibre, make sure your interconnects are on separate backplanes. Usually we want redundant cards in there so that if one fails, we just get an email and nobody notices. Every one of these HBAs has a default queue depth. Usually, the faster you go, you'll see a queue depth of 32 or 64. For all-flash storage, it's simply not fast enough. That's a real problem because I can't blame them. They don't know what kind of storage you're connecting. If you've got good storage or really good, that fundamental bottleneck right there is one of your biggest pinch points of your entire storage up and down stack. They don't know. So they set this to literally one of the lowest values that they can because they don't want to overwhelm cheap storage. Well, if you're running good storage, fix that. Sometimes it's in the BIOS of the card. Sometimes it's through a driver in the operating system. VMware's got them in there. Go validate that. Check with your storage vendor. See what they recommend. A lot of times these are set far too low. Now, if you're running network adapters, same kind of thing. Make sure the interconnects are on separate backplanes, multiple cards, multiple ports. Depending on your budget, you may be looking at things like RDMA or RDMA over Converged Ethernet called Rocky. You really should enable a lot of this stuff if you have it available to you. That latency round trip on the network could actually become the primary bottleneck to storage performance if you've got really good storage. If you've got a blade environment, you need to watch out for this. A lot of times, the network adapters and the blade adapters that we see at the physical blade layer may not be actually real. They may be virtually presented blades, and the back of the blade enclosure may only have a couple of adapters on there. Cisco UCS is a prime example of this. And guess what? Just like the other stuff, you've got some defaults in there that are honestly really terrible. So if you're running Cisco UCS, look at the FCOE adapter blade policy. So there's one for VMware, Windows, Linux. Go look at the LUN queue depth. Most of the other HBAs you're going to find have a queue depth max of 32 or 64 with a maximum of 256, 512. This thing is set to 20 as a default. It is literally like putting square tires on an Italian supercar. Next step, virtualization. So regardless of the hypervisor, guess what? Every single request from that virtual machine has to traverse the hypervisor resource scheduling queue in order to make it there. So CPU, memory, network, disk, all of them have individual schedulers and individual queues. And if these queues are choked up anywhere, you end up with a problem. So first of all, start at the bottom inside VMware specifically. Look at the VM kernel, the VHBA QDepth adapter. If you've changed this inside your physical hardware from 20 or 32 or 64 and you bumped it up, check to see if you need to change it inside VMware. There's a specific KB article here that'll help you with this. But if you've changed it there, you probably need to change it here. Otherwise, you're not going to get a bit of difference out of it. If you're running the Iscsi initiator, the default queue depth is 128. So by default, it's usually double or 4 times what an HBA queue depth is actually set to. Now, again, same thing. If you're using an all-flash or an NVMe array, consider updating this. It really does make a big difference. There's a link on the screen here for how to do this with VMware. It's another one of those things that can hold you back if you've got really good storage. Now, VMware also has a really interesting setting that not many people are aware of. It's called disk.schednum rec outstanding, or DSNRO. Think of it this way. VMware, whoever originally came up with this a long time ago, they thought VMware was the center of their universe. A virtual machine and its dependent virtual disks are called a world. If that exists, and only that one virtual machine exists on a VMFS formatted data store, the queue depth from that host to that data store is inherited from what the virtual machine is sending it. So the disk controllers, the number of controllers, the type, things like that. Now, here's the challenge. How rare is it actual for us to deploy a single VM on a data store? Most of the time, we have larger shared data stores. This is where this gets into challenges. If we have more than one world on a data store, the default queue depth at that host to that data store drops to a value of just 32. That's terrible. That's absolutely too low for any of the kinds of storage you're going to be running today, especially if you're on all-flash or flash hybrid or NVMe storage. I highly recommend that you go update this value. Go check out the link on the screen there, or just simply do a Google search or Bing or whatever you use for DSNRO VMware. You're going to find out how to check this. Now, test, validate. Make sure that you don't actually see higher storage bottlenecking inside the guest, because if you don't set this right, it can actually slow you down. Now, if you're running NFS, same kind of stuff. There's queues built into this as well. So NFS.max volumes, TCP heap size, TCP heap max. There's also one for the VMNIC receive ring size. Go check that link on the screen there. Go see if you actually need to deal with stuff like LACP for port redundancy or port aggregation, or if there's any of these settings that your storage vendor actually recommends that you go tune. Now, let's go to the next layer up. Let's hit the virtual machine configuration. So now, with our virtual machine hardware, this is what is, quote, seen by that guest operating system as being actual hardware. So we've got virtual CPUs, and I could go on for hours about virtual machine CPUs. There's virtual machine memory. There's virtual CD drives. I can do virtual floppy drive if I want to. But then there's virtual disks and disk controllers. Those are big. Those are highlighted on here because they're really critical for storage. And then there's virtual machine NICs. And if you're doing in-guest Iscsi or NFS or SMB, you got to pay a lot of attention to those as well. We're going to start with the disk controller. Every virtual machine, these virtual disks are connected to virtual machine disk controllers. It's the same as a physical machine. You don't just directly connect them. You have a controller of some kind. This is what does the I/O coalescing and queuing by controller. The guest operating system will do this, Windows, Linux, whatever. Now, the default controller for both VMware and Hyper-V is the LSI Logic SAS controller. And this is everything from 2012 all the way up. Now, it's there for compatibility. There's another type that I personally like to use. It's the VMware Para Virtual SCSI or PV SCSI controller. Then there's NVMe. Now you get a max of 4 of these disk controllers to the SCSI type per virtual machine. You can also add 4 NVMe controllers if you're on a more modern build of VMware. The SAS controller is the default. When you go just right-click, add a disk, this is what it creates. They do that because of compatibility. The driver for this thing is built into the operating system. You don't have to do anything fancy with driver injection or anything like that, but it's there for compatibility and not really for performance. It has a single maximum queue depth of 32. It's default in VMware. It's default in Hyper-V. This is what you get. Now, you can go change this, or you can add another one in here. So there's a VMware type Paravirtual SCSI or PV SCSI controller. I love this thing. It's included with the VMware tools, but you're installing that, so you have this already. You get better performance. It's built for speed and resiliency and redundancy. It has a default I/O queue depth, not of 32 like the old one, but of 64. And with the registry setting, we can bump this up to a max value of 254. The interesting thing is driver updates are now coming through Windows Update, which is really cool because now we can keep this thing up to date as well. Now, if you're on a more modern build of VMware and you have true NVMe storage under the hood, you can use an additional new controller type called the NVMe controller. I stress with this, you have to be running really solid storage in order to be able to see the benefits from this. Instead of one queue with a queue depth of 64 or 254, you get 16 I/O queues. One is for administrative management, 15 for I/O usage. You get a maximum device queue depth of 256, but you have an additional 4,000 in-flight commands per controller. Again, be careful. You have to have NVMe storage underneath, and there's a little gotcha here. The part of the standard did not include rescanning and hot growing a disk without a reboot. So if you've got a 1 terabyte SQL Server log and you're out of space and you need to add more space to this drive, you can expand the virtual disk, but it will not see it in guest until you reboot that virtual machine. So it's a real big caveat there, but you do get a little bit better performance than the Paravirtual. Now the connected disks here, the count, a lot of times we're running some pretty big stuff. So we need to figure out how much of this can we actually expand outwards. You have an IDE controller, you get 4. Don't use that. It's trash. SCSI or SAS, on VMware, you get a maximum number of 60 disks on the LSI controller. Paravirtual SCSI, by controller, 256. There is a SATA controller in there, but again, super low queue depth. The NVMe gets 60 per controller. Hyper-V, if you're on that, limits to 64 per controller. Zoom out and zoom up. We now have the solid foundation for serious performance queues. Now we hit the SQL Server layer. Common practice by DBAs has always been to add more drives and spread this information out. So database data, log files, tempdb, if they're doing local backup, spread those out. They always knew it was faster. They may not have known why. Same thing comes along on VMware. More drives, more controllers, better I/O queuing, both by disk and by disk controller, and then start to spread out your objects. So it starts with, how do we spread this stuff out to begin with? Well, take a look at what you've got. On the screen is a starting point. We've got 1 or more drives for data. We have 1 or more drives for database transaction logs. We've got our tempdb databases. We may do local backups. We may write them over the network, whatever we need to do. If you're doing a highly available architecture where some of the system databases get beat up on pretty bad, you may have a different drive for those. We may have a drive for our SQL Server installation, and then you got the operating system itself. Use Windows Perfmon or any third-party telemetry measuring tool that you've got in order to go figure out how to balance these individual drives across the controllers that you have available to you. Now, a lot of people out there are like, I don't know what to do. Well, it's a hard situation, but there are things you can do about this. So one, you don't have to spend any money if you don't have the budget for a third-party utility, and there are some good ones out there. Use Windows Perfmon. It's built into Windows. We have a free Perfmon setup guide out at the link on the screen here. There's no contact info required. We don't ask for your name or anything. It's literally just a PDF. It shows you how to set up Perfmon the way we like it. Now, The other fun part here is everybody on the internet tells you to go collect perfmon, but nobody tells you what to do about it. Well, if you go out to GitHub at the link on the screen there, we have released some PowerShell that will allow you to take that BLG file from perfmon and load it into a SQL Server. So now all the native tooling that we use every single day, so Tableau, Power BI, T-SQL, Excel, whatever you want, you can now get to the raw data and start to mine it to actually go look for a lot of these trends, which is super cool. Now we've hit the database layer itself, and we're looking at distribution in here. So that thing I was talking about at the very beginning, disk stall, it is SQL Server's perspective on storage latency. It's measured by the database data or log file. Now, if you go to Glenn Berry's diagnostics, so Glenn with 2 N's, SQLperformance.com, go to resources. He's got some diagnostic scripts out there that are fantastic. Gives you the average disk stall since the last time the SQL Server was restarted. I claim that you're going to have varying patterns all over the place. So in the middle of backups, integrity checks, whatever, it's going to be very different throughout the day. So what I always say, sample it periodically for point-in-time metrics. And if you do them at the same granularity as perfmon, you can start to actually go see this stuff side by side. We have an example out there, out at that link on the screen. It takes you to our website. Again, no contact info required, but it'll show you how to actually go collect this stuff around the clock periodically, every 30 seconds to a minute. And then you can turn around, look at the stall by file, and then look at the volume that it's on with perfmon, and then look at that virtual disk with VMware. And this is why, when we start to put this stuff end to end, you've now tuned the SAN, you've tuned the interconnects, you've tuned the hypervisor, we've tuned the virtual machine configuration. All of those metrics should line up really well at this point. A little bit of overhead in there. So, if the SAN says 0.8 milliseconds, VMware might show 1.410, something like that. That's good. That's not that big of a deal. If you're still seeing ridiculous disk stall inside the database, now we got to go a little bit further. So we talked a lot about how to distribute the virtual machine disks by controller. Now we have to go one step further. We have to validate where's our hotspots of data, and do we need to go beyond this and actually have more data drives in here and spread the data out logically within the database? So this goes back to how are the databases actually interacting with the applications? So if you've got a database that's got a single data file, if it's small, it's not that big of a deal. It's the default, most ISVs ship this way. But if this database gets larger and larger over time, the metadata management for all of that data becomes a hotspot. And you can start to see PFS or SCAM contention, and you can actually start to have just that concentration of I/O into a single file start to slow you down. So what's the workload actually doing? We can have commonly joined tables. So it could be things like order history and inventory data, or people and addresses. If you're really joining a lot of common tables, maybe it's contributing to very large I/O scans or a lot of activity on a single database file if that's the only file in the file group. And then start to understand the patterns between your data and indexes. There's non-clustered index access, and things could be seeking to data if it's really efficient, but most of the time it's probably doing scans. And it may be doing scans on a portion of a table, and it becomes an I/O hotspot. Now, ISVs are really notorious for this, and you got to be really careful. We don't want to make any changes to the database structure to get you out of warranty, something they wouldn't support. But if you explain what you're doing to them, you might be okay. The goal here, spread out this workload. So a file group inside a database is just a logical container of one or more virtual database files. And that allows it to, concentrate in one if you just have one, or it can kind of round robin between them. I want to see more file groups, and each file group by default has one. I want to see more than one data file in there. We do this for the TempDB database by default, and we have for decades. Why not do this with your user databases as well? And this is where if we can move the data appropriately, so maybe a non-clustered index file group, we got a primary file group for metadata, maybe a data 1 file group for customer demographic info, and a data 2 file group for purchase data, and a data 3 file group for product data, however it lines up there. And then we have a number of virtual drives. We don't have to go crazy with them, but we need this logical separation. So we turn around and we split up these file groups onto more drives. And then if you zoom out a little bit, the virtual machine layer, then we can use perfmon and any other telemetry that we've got in order to figure out how to connect these to the individual virtual disk controllers to minimize the amount of queue bottlenecking that we're actually going to see. Now, how do we move this data? That's one of the hard parts. So we have to deal with it a lot of different ways. There's the table itself, the raw data. So what you can do, you can rebuild a cluster index, specify a new file group, and away you go. If you're on Enterprise, you can do this online. If it's not Enterprise, but Standard Edition, you might have to wait for this thing to rebuild onto the new file group. If it's a non-clustered index, this is more of a list of pointers to the data that we care about. Simply rebuild it with the new file group specified. Now, how do we spread out the file group? There's a couple of different ways in here. One is with a DBA PowerShell module that I love called DBA Tools. This way is fast. What it does is it will redistribute the data in these data files by simply rebuilding all of the indexes. It can impose table locks, but it is fast. If you want to read more about this, go out to dbatools.io, hit the link on the screen there, and you can actually go read up more about it. And it's super cool. I have a way to do it that is online for both standard and enterprise. And what you do, you drain the files. So here's what you do. Let's just say you inherited a database and it's got a massive MDF or primary database data file. Add more to this file group. Now this gets away from the discussion on more file groups, but again, we got to be safe so we don't break third-party vendor support. Add more, start small. Now, how many do we add? So let's just say we add 7 to go from 1 to 8. Calculate 1/8 of the data inside the MDF file. Set the cap on that NDF file growth to that value. What we are essentially going to do now is drain this original file, and it's going to round robin spill it into all the new files. But by doing this, we now capped the growth. So if it drains completely, we'll end up with the contents of the MDF being the same as the contents of the NDF in terms of space. So here's the command, dbcc shrink file, and then the logical file name of that MDF file and empty file. When this thing runs, it essentially will drain into all the other files by kind of pulling the data out of there. It will fail when this step hits equilibrium in there, and that's okay. Here's that error message you see. Cannot move all contents of the file to other places to complete the empty file operation because the file group is full. That's fine. I'm fine with that thing failing like that. Now, when this is done, run the shrink file command to shrink that MDF down to the same file as all the new NDFs. And at that point, check the auto grow all files. There's a trace flag for this as well if you want to do it at the instance level instead of the database. At this point, SQL Server is going to be able to round robin between all of these data files equally, and you end up with better concurrency, better speed, better query parallelism, just everything gets more efficient. You'll also watch your disk stall rates drop considerably. Now, this is slower than the index rebuild, but it is an online operation. You can do this even if you're using Standard Edition. It's safe. I've done this live while people are using the systems. Nobody noticed. There might be a small amount of IO drain in the background, a little bit of a drag on it, so let people know. But realistically, it's a great way to distribute this stuff. Can be incremental. If you don't have a lot of free space, shrink it a little bit, spread it out. Shrink it a little bit, spread it out. Takes longer, but it works. You can go through a lot of iterations on this. Rebaseline that disk stall after that process has been completed. Give it a couple of days. Again, full details here. And just a raw example, if I want to do a storage read test within SQL Server, Look at a backup to disk. No. Don't do this on a live system unless you do copy only. It's a storage retest. You're backing it up by reading it, but it's not writing it anywhere. So it's not even a real backup. Now, if you go with one data file on here, and this is a 500 gig database, 941 megabytes a second. If we go to 8 data files, you'll see a little bit over 2 times that bottlenecking potential in there. So 2.2 gigabytes a second. That's as fast as my lab could go, 2 by 10 gig connections. That's just simply 8 data files. There were no code changes in there. So here's the process. We've tuned the SAN, then tune your interconnects, then tune the physical server, then tune virtualization, and then tune SQL Server for your workload as appropriate for the demand that your databases and those applications are placing on your storage end to end. Now, whatever you want to do here, question everything. Just test this stuff. Not all environments are created equal. You may find that you get better results with certain settings that may be contrary to what you see published on the internet or here or even from the vendor. A lot of times they don't get it right. So test and verify, but I promise you, you will see gains if you go through these steps. Thank you, everybody, for listening. And now let's open this for some questions.
All right, David, great stuff. I enjoyed the Lambo with the square tires, but on the serious side, there's a lot of blood, sweat, and tears evident behind all these best practices. And I know I'm not alone in appreciating you saving us some of that pain with these rules and tips. From the audience, Neil says thank you, and James says very interesting. I did not know about the queue depths. So you're showing people stuff. That's great. You ready for some questions?
I am.
Awesome. Okay. Hey, let's start with the broad one here. Which item that you talked about is usually the largest bottleneck or impediment to performance?
Absolutely. Yeah, this is when things have changed over time. It used to be the underlying storage itself. Just spindles just couldn't keep up. But that's getting better and better and better, faster than a lot of these defaults. So if we look at it today, it's probably going to be the DSNRO setting. A lot of times it's just simply way too low by default everywhere. And it's an absolute nightmare. It's not that hard to clean up once you know where it's at, but nobody knows where it's at.
Gotcha. We've got a question here from Jonathan who's wondering, is it possible to set up tiered storage within a VM world? Or is this something the hypervisor should be running?
Oh, that's a good question. Usually, if you're doing tiered storage, it's usually inside the storage array itself. And you really don't have to worry about it. If you're looking at more tiered storage, where maybe it's multiple LUNs, of a storage type, then that would be up to you to go set up as different data stores inside the VMware layer. At that point, you would place whatever objects on which tier that it really belongs on. There used to be some host level caching options. There's not as many anymore. Those would be ones that would be managed by the hypervisor, but those are they're pretty rare to actually see in the wild now.
Okay. All right, great. A question here from Jason, wondering, can these changes be made on VMware ESXi hosts without downtime, or is it a live change?
Very good question. You're going to want to take the host down to make these changes. If you have to get in and change the HBA queue depth, that's definitely an outage because you got to reboot the machine, get into the BIOS usually, or it's a driver change in VMware and then a restart. DSNRO technically is live, but I still like to restart the host after I make that level of change. Anything above that is going to be at the data store layer from a host perspective, and then that goes back to more storage vMotion, so you don't have to take an outage if you're licensed for that. Changing the disk controller at the virtual machine is definitely an outage, but it's fairly quick. It's essentially shut the VM down, click about 3 or 4 times, bring it back up, and that part is fairly quick, but it's still an outage.
Okay. All right, super. This next one is from Jason is wondering, using NVMe VMware controller, does the array need to be NVMe only, or do we also need an NVMe capable FC switches?
Very good question. If the array itself is NVMe, you will see a small gain by using the NVMe controller. You don't need things like Rocky or NVMe over Fabric switches themselves, but if your storage array is super fast, and there are a few that come to mind, but I'm not going to name names. If you have those, you will get the most out of the array if you do upgrade the switches. They're pretty rare, but they're really important if you have that kind of a workload that needs them.
Okay. All right, super. Next question comes from Matt. He's wondering, is it recommended that you run separate SANs for databases versus normal server workloads such as file servers and
Ooh,
whatnot?
that's a great question. Is it recommended? Standard DBA answer here. It depends. Realistically, if you've got the budget for it, it would allow you to set up that storage array specifically for database workloads. Now, some arrays don't have as many bells and whistles for it, and some of them flat out don't need it. But if you've got a lot of demand on your entire platform, so file server, media, app, and then database, you'd probably want to separate them out. But that's kind of on the extreme. Most of the time, if the array is fast enough, we find that they can coexist pretty well together, as long as you separate them from a LUN perspective, and just keep an eye on it to make sure that the demand on the disk pool isn't slowing anybody down.
Okay. All right, great. Another question here is probably going to, I predict be another sort of DBA it depends answer, but this one from Matt. I was wondering, is it recommended to use more than one virtual controller to split the workload of a database, such as
That's a
snapshots,
great question.
et cetera?
Yeah, if you're using more than one controller at the virtual machine layer, you have the maximum possible number of queues. So to me, regardless of the array underneath, I don't want that layer, the storage controller layer at the virtual machine. I don't want that to be the bottleneck. So my default, 4 SCSI controllers. Simple as that. If you're on all NVMe, you can add NVMe or replace the SCSI with NVMe. Either way, I want the maximum number of queues there. So that's my personal starting point, is literally spread it out as wide as you can. And that way, if that layer is ever going to be a bottleneck, you pushed it way, way, way down the road instead of hitting it day one.
Okay. All right. Next question comes from Ernesto, and forgive me if I butcher the acronyms here, but with a focus on queue depths, how do you see newer fabrics, ROCE, NVMe, OF, etc., lessening that importance?
Ooh, great question. You're playing on the bleeding edge. That's fun. Essentially, as the interconnect topology gets faster, the queue depth at the interconnect will matter less, because the queue depth at that layer itself is already so high, and or it has the ability to push those commands through as fast as humanly possible. But if you clean those up, you're still going to hit these queues on top of it. And that's where they become an even bigger bottleneck to performance. And if you're currently seeing, 4 millisecond response time, and you fix those queues up and you go to half a millisecond, that's still an 8 times performance, like overall exhibited speed gain. And that's the kind of stuff that really separates the okay workloads from the really good workloads. So, it's just like fixing any bottleneck. Once you clean one layer up, the layer above that usually becomes the principal bottleneck. And in this case, that's exactly what would happen.
Okay, super. Here's a nice general question from Thomas. It says, "Hi Dave, what do you feel is the most common storage configuration issue that you encounter?"
Ooh. In terms of storage itself, I'd have to ask a question on which layer, because if you're looking at the SAN itself, then usually it's number of LUNs and the controller CPU in addition to the interconnects in between that SAN controller and the host. So it really depends on the kind of array you've got. Some arrays have overbuilt controllers. Some arrays have multiple active controllers, and you can tend to work through a lot of those things. But other times, on some arrays, maybe they've got deduplication and compression features, but those are very, very CPU intensive. And if the controllers are, pretty underpowered, that may actually become the bigger bottleneck. Rarely is it the disk pool anymore when we're talking about solid state, so that's usually not that big of a deal anymore. But usually it's controllers on the CPUs on the controllers, or the interconnect itself once you get out of the SAN itself.
Okay, great. Hey, next question here is from Deepak, who's wondering, what is the cost estimation for storing data on VMware? Does it depend on terabytes being stored or flat rate? What's recommended?
Oh, that one is very dependent. It's essentially, since you're not using attached storage directly, and VMware doesn't license off the storage unless you're on vSAN, and that's a little bit different. If you're just dealing with a regular SAN, then it's going to be whatever the cost of that underlying storage array actually is, just calculated down to the terabyte. If you're using vSAN, it's similar, where the license based off of the host that you have, and then it's essentially how many drives can you cram inside that physical machine and add it to the vSAN pool.
Okay. All right, great. And by the way, Matt chimed in. Thank you on your controller answer. So it looks like you hit what he was looking for. So that's great.
Awesome.
This next question is, why doesn't VMware tune a lot of these by default so we don't have to?
I wish I had an answer to that question. And I'm not trying to knock VMware. I mean, Microsoft does a lot of this. VMware does, Hyper-V, Cloud, all those layers. I think it's honestly because it is a state change in an expected behavior, and because they don't understand directly the class of storage that you have underneath. They want to make sure that their platform is not going to push too much overwhelming load to an underpowered storage device. So they err on the side of caution. But that's a hard one because by default, these bottlenecks are the primary bottleneck to storage on almost all storage arrays on the planet at this point. So I've put in a number of requests, and a lot of times it falls on deaf ears because I'm just one person, but they know the kind of storage that you have. They have storage DRS and, a lot of storage IO control. They know what's there, but it's just like with a lot of other defaults that have been that way for a long time. So Hyper-V, AHV, a lot of those things are all included. They don't want to change people's expected behavior because they can't guarantee that that change is going to produce a positive effect.
Thomas adds, low default values from vendors provides Dave with work. So
You know what?
you
I
go.
wish it did. I wish it didn't, but unfortunately it does.
Yeah. Another question here. Do you have any specific recommendations for hyperconverged, specifically all flash hyperconverged?
Ooh, that's a good one. I could spend a couple hours on this one. Long story short, all the recommendations around a 64K block size, I don't apply those to hyperconverged, and that's inside the virtual machine. What I would want you to do is, this is contrary to a lot of the vendor documentation, but hyperconverged is generally, it has a higher latency characteristic than a regular all flash array, largely around the block size. So what I tell people is test and verify at a 4K block and then an 8K block, and then compare to the recommended 64K block. And a lot of times you'll find that the smaller block size with a database workload will actually get you better results. Now, the other component there, and this is just something in general with hyperconverged, if you are pushing the hyperconverged layer, watch the CPU scheduling overhead that it's going to impose on the virtual machines on those hosts. A lot of times, these controlling appliances for the vSAN or Nutanix layer, whichever platform out there, those appliances can eat more CPU and memory than you might realize. And they take first dibs at all the available CPU and memory at the host. So if you're pushing those layers hard, it might actually slow down your SQL Server workloads. And again, you need to test and confirm this. But I see this more than I care to admit, and I just simply want to make sure that you're aware of that. So it's one big caveat to hyperconverged with big databases.
Okay, great. Hey, well, it looks like we're running out of time, David, but just how much deeper do we need to go to get the best out of our data platforms?
Oh my goodness, you could spend days digging in on this stuff. As a quick little pitch for us, I put together an 8.5 hour intensive deep dive series on this exact topics: performance tuning and availability for SQL Server on VMware. If you go out to SQLibrium.com, you'll find that package out there. Let me know if anybody has any questions on this, but I wanted to put really all of the stuff that I look for in terms of health checks and overall performance and these weird bottlenecks that you'd spend days and months chasing down. I wanted to get all that in a format where you could actually sign up and go check a lot of that stuff out. So if anybody has any questions with it, let me know.
Okay, and that was SQLibrium.com?
Correct, yeah.
Okay. And of course, this is, part one in a 4-part series on SQL and VMware, and I'm looking forward to your next installment on March 18th, and then one on April 22nd. But next time is about optimizing SQL Server on VMware for disaster recovery. Can you give us any kind of preview on what you'll be talking about on that one?
Absolutely. Yeah. When you talk disaster recovery and high availability by extension, it's this topic that tends to trigger a lot of DBAs in more of an adversarial role against the systems folks who have to deal with DR at a bigger perspective. And it boils down to, what does the business actually need? Both RPO and RTO, mean time to recovery, those sort of things. And then sitting back and looking at all the available options. And that's a tough one because there's a lot of really good options from a VM and infrastructure perspective. And there's also a lot of really good options from a database server perspective. In a lot of cases, they don't meet in the middle on this stuff. So it goes beyond the tech. What does the business actually need? And then here's this myriad of options in front of you. What's the right one for you? What's the right one for a given system? And is it by tier? Is it by technology? Is it by who's actually managing DR? There's so many factors in with it, and there's not an easy answer to it. So there's going to be a lot of it depends, and you should think about this, but it's going to be a fun session.
That's awesome. That sounds really good. I'm looking forward to it. Well, David, thanks for putting together such a content-rich session, although, it sounds like it's only scratching the surface of what you've got there at SQLibrium.com as well. But I know this has been incredibly valuable, and thank you for your time.
Awesome. You're welcome. Thank you for having me, and thank you everybody for watching. My contact info is here. If you have any questions long-term or any deeper techie questions with this stuff, everybody don't hesitate to reach out. I'm a geek with this stuff. I just want to fix things.
Awesome. All right. And before we do wrap up, we have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of the $300 Amazon gift card is Jason Moorhead from Texas. So congratulations to Jason. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank everyone for attending, and I'd like to thank Pure Storage for making this event possible. That concludes today's event. Join us next week for our Expert Series webinar on A to Z of defending yourself against ransomware with Alan Liska. And then the following Friday, as we talked about, when David Klee returns to talk about optimizing SQL Server on VMware for disaster recovery. We'll see you next time.